everyone and welcome. So today we're going to be playing around with some fun and easy beginner lighting patterns with our LED strip and Arduino. And this is all to come up with a cool lighting theme for our cathedral window lightning detector. I'm Rachel DeBarros and thanks for watching Gearhead Diva. So we got some of you already showing up. Hey, Kurt Benning, and welcome. I'm trying to put this down as gracefully as possible here. And a lot of you guys have been following this project from the beginning. We started out with a simple lightning detector that I was going to hook up to an LCD screen. Sounds simple enough, right? But then you guys started chiming in some amazing ideas of how we can really take this lightning detector to another level. Maybe something that just hasn't been done before. And so the more we started to plan together, that whole cathedral window started coming about. And so we went ahead and made this out of plywood. We put some PVC trim to make it look kind of like gothic and stuff. And since we had a window, well, we needed a scene to look out upon, right? So that's when we kind of took our Bob Ross inspired night scene and we gave it a go with acrylic paint. Now, of course, he uses oil, but we managed to come up with a nice stormy scene here with acrylics. So finally, how are we gonna hook all this up to a lightning detector? How are we gonna even know that lightning is around? So the first idea I had was to make a cool little lightning bolt that would come down and just illuminate. Now this was either gonna be LEDs, like an LED strip like this, or maybe an EL wire that just blinks on and off when the lightning detector detects lightning. So that was one idea. And then of course you guys started chiming in even way better ideas than mine. So I'm like, yeah, I'm gonna steal them. I mean, borrow your ideas for this. And instead of painting a flat scene like Bob Ross, since we are doing so much lightning inspired stuff, I mean, what do you think of when you think of lightning? I mean, I think of Frankenstein, right? So then of course the project evolved a little bit more where we started making miniatures. Now this is not complete quite yet, but this is a replica of that young Frankenstein's castle, Dr. Frankenstein's castle. And of course I have a special tower here for Frau Blücher. I didn't hear any horses, so we'll call her FB, you know, so the horses can't tell. Hopefully the horses can't spell. So that's where she lives. Of course, we have Dr. Frankenstein's tower right here that looks all kind of decrepit. And of course, you know, we're still finishing up roofs and things. I'm trying to power through this miniature so that way we can add it to our scene. And I thought, wouldn't it be cool if we had a lightning bolt coming from the sky and hitting the Dr. Frankenstein tower? And then it evolved from there where me and Wrench Army members, we came up with a cool mini fog machine that we're going to hide back here. And the fog is going to escape these broken holes over the, Castle Frankenstein's poor crumbling roof here. And of course, we need a reservoir for our fog juice. And so we came up with a bubbler, which is another like iconic Frankenstein thing, you know, just bubblers, Tesla coils, Jacob's ladders. So we're incorporating all these cool Frankenstein things into this build. So we got to the point where we have all these cool components and now we need to find a way to bring it together. And the cathedral window, a lot of components going on here, but the cathedral window is a very cool thing. We can hang it up, but it's kind of lame that we need lightning to make it do anything, and it's just gonna sit there kind of, you know, doing nothing until lightning hits. And I don't know about you, but I live in an area where we do get storms, but they're not like every week. So it could be months before I see this thing, you know, illuminate. So I figured, why don't we try and create a lighting scene for when there is no lightning, right? Maybe something that pulses, or maybe the sky can be blue. And then coming up with some ideas for when the lightning detector detects lightning. So I thought that we can add 3D clouds, like with cotton balls, where we can hide LEDs underneath and have them just blink on and off real quick. This can be tied in conjunction to our lightning bolt, and perhaps we can even hide some LEDs at the very top here of our frame, because we do have a little alcove so we can hide LEDs here that also flash. So all working together to create a very stormy lightning scene for our Frankenstein. And of course, all this does is tell us to prepare our creation because lightning is nearby and it's going to awaken it. So that's the whole point of this lightning detector. It's not to like study weather phenomenon. It's to potentially awaken creation. So I see a couple more of you guys joining. So Frank and Azola. Yes, that's Andazola. That's an L. Hello, Rachel. Miss you on All Girls. Good to see you here. Heck yeah, I am here just about every week. A lot of times, 2 times a week. So let's get dived into this. Now I have like a couple notes here so I don't forget, to go over some things or jump, far too ahead. And when I started this, I mean, I gotta be honest, I have never programmed lighting or anything like that. I have some nice LEDs under my kitchen counters, but that's more like you have a little controller and you can choose the colors and the different color patterns. And I suppose we could have done something like this, but I wanted to tie this to the lightning detector so that way the lightning detector drives what's going on with this strip. But before we start all that, we kind of got to figure out how this thing works and maybe start deciding on a color scheme. So while you guys jump on, I'm just going to check here, make sure that our internet is still up. We had some wonkiness earlier today, so all looks good. All right, so we've worked with LEDs in the past. You remember Fartatucus, our fart detector? Yeah. And with LED eyes, and so we used green LEDs, and I'm talking about the little bulbs, like the 5mm bulbs. And the problem is, and I'll give you guys a much better look here, the problem with that is if you look at this Arduino board, and I'm going to zoom you guys in, yeah, for maximum viewage. So the problem with this Arduino board here is you see a series of pins going down here and a few over here. And if you want to hook up like a bunch of LEDs like we're going to, we're probably not going to go over 100 LEDs. But you can quickly see we're going to run out of pins here. And so instead of hooking up individual LEDs, what a strip allows you to do is basically run hundreds of them off of just one pin. And right here we're using pin number 2, and we'll talk about the hookup here in a second. So there's huge advantages to using a LED strip like this because you can create a ton of lighting scenes. So looking at it, and Bounty Hunter Breaks is asking pi 2/3 or 4. Not quite sure what you're asking, but this is an Arduino Uno, so this is not Raspberry Pi. We're going to use a basic Arduino because I thought, let's just keep this like beginner friendly. Oftentimes when you start with Arduino and your first programs, the first board a lot of people learn on is the Uno, or a board that's like an Uno. There's several companies that produce this board. It doesn't have to necessarily be from, Arduino. So that's how we're starting. I found it really easy to learn for someone who is a total beginner and has never done this before. So I'm hoping that this will be kind of a good beginner's crash course for you guys too. So making sure I'm not forgetting anything. So of course the basic things that you're going to need is some kind of microcontroller. Now a lot of these LED strips support a lot of these microcontrollers. So you can always look at your microcontroller and the LED library that you're going to use. We in particular are going to be using the FastLED library. I've also heard it pronounced FastLED library. So I will equally interchange between the two of them to equally offend, the maximum amount of people. Bounty Hunter is saying, that after I asked, silly me, yes, trust me, you are not the first. I'm going to do a lot of silliness today, trying to figure out like this code with you guys. But looking at this strip, and I'll flip you guys back over here and just put this like that. So this strip, as you look at it, it's got, some LEDs, and these strips come in different densities. There's 30 LEDs per meter, this is 60 LEDs per meter, or 144 LEDs per meter. There's other combinations, but just searching online, those seem to be the most popular. And again, this is in 60 LEDs per meter. I found that 60 is just kind of a good general all-purpose, gives you enough light. With the 30, you kind of have way more gaps in between. And the 144 is nice because they're all really close together. So it's a lot easier to lose the little single LED effect that you get sometimes. But the more LEDs that you pack in, the more you have to think about your power requirements. So looking at the butt end of this LED strip, which is the exact same as the front end, the head end of the LED strip, mine came with these connections. And so I have power and ground, white being ground, and then I have this little connector, which is convenient if you're going to connect it to some kind of controller or something else that already comes ready to go. For our purposes, we're going to be putting it right into the Arduino. So of course we have our power, our ground, and this green wire, which is our data line. And so this will go into one of the pins of the Arduino. Now, you have to make sure, since we're using the FastLED library, that this strip is compatible. And it is. I checked that. So this is the WS2818B, I believe. It's linked at the bottom, So we'll see how this strip works. If it doesn't work too good, then, don't click the link, buy another one, But if it works well, at least you can say, hey, she used this one, and hopefully it'll work for me too. So this is all my stuff. No sponsors. This is me and you guys trying to figure this out. So we can say what we want, right? That's the best. All right. So we went over what you need. Power requirements. This is really important that I learned. These strips come in different power varieties. You can get the 5 volt, which is what this is, or you can get the 12 volt. Now, of course, the more voltage, the more LEDs you can power, the more voltage drop, the less voltage drop that you experience. But when you go 12 volts, you have to remember that a lot of Arduino components that you use are right around the 3 to 5 volt range. So now you kind of got a mix match of voltages that you have to power this separately, or use like a buck converter or something, but it adds some more considerations to your power requirements. So if you're a total beginner just starting out, it's not like you're going to power thousands of LEDs. Something like this is more than enough. So 5 volts for me, 60, which is like a medium density, 60 LEDs or pixels per meter. This is about 16 meters, I believe, in here. So we can make lots of mistakes, and keep going. Hopefully not burn out too many of these in our experimentation. So after that, we talked about density. You'll also notice that this particular one is not waterproofed. So you can see that I can touch the LEDs and you can access everything. It's got this little adhesive tape that you can remove and kind of, stick anywhere you want. But the nice thing with these LEDs is that you'll notice this gold contacts. Now you can cut the LED anywhere where there's gold, separate them. So say you need to kind of like turn a corner and you don't want to waste LEDs. Well, you can cut right here, solder jumper wires to each of these 3 contacts and then continue, which is something that I think we're going to do for our thundercloud. Because if we have our scene right here and I decide to put some cotton, we'll pull them out, make them look as natural as we can. We can put some like a cloud here, here, here. Say we want to spread them out. Well, I can cut 3 LEDs and connect them via wires. Put one here, put one here, and put one here. And we'll like drill little holes through the back here where they'll pop out and illuminate the cotton balls. So I think that'll look really cool. So that's another advantage. Now, of course, if all you're doing is thunderclouds, the 5 millimeter or 3 millimeter LED actual light bulbs work just fine because you're just using 3. But we want to create more lighting scenes. So I figured let's learn this LED stuff, so we can start making some cool things. And David Beck has joined us, better late than never. Light it up. All right, he's ready to see lights. He's like, okay, enough. Let's move this along. Let's see some lights. I feel the same way. So let's check out how this is hooked up real quick before we move along. And I'm just going to back us up because holy closeness, Batman. Let's back this up and see what's going on. So we have our strip here, and I'm just going to like roll it back. Let's just roll this thing back. And for right now, because I'm not soldering anything, I'm hooking it up through a breadboard. just to make our lives easier. So anytime you're hooking up to, we have our strip here, and if you look super close, and I lied, I was like, I'm gonna back you guys up. No, now I'm gonna bring you all in. Let's see if it'll focus. Let's see if it'll focus. All right, as if I talk quieter, it'll focus. It's like, yeah, no, that's not how it works. All right, so looking at the strip, you're gonna see this little arrow here and this little arrow. And that's a direction that the data flows. So although you can inject power from the butt end and the head end, from the head and the tail, I should say, the data has to be connected a specific way. So you want it to come from the Arduino and flow through the wire and connect to the LED strip that way. So hugely important, because then you'll be troubleshooting like, why is nothing working? And that's why. So trust me, I am happy to admit all of my mistakes, so that way you guys can get a jump start and not make them, right? So our breadboard, and so here's the data line. And just like the arrow said, the information is coming from the breadboard. It's hooked up via 2 resistors into the data line that then goes whoop, to the rest of the LED. Now, it's important for your data line to use like a 300 to 500 ohm resistor on there. And that just prevents like spikes in the data line from damaging this first pixel right here. I have 2 because that's kind of what I had on hand. So each one is 220. So add them up, you get close to 500. So you get in that range. So I had to kind of piggyback that way. So it's coming from pin number 2. So we want to remember what pin we hook this up to. Now you can pretty much hook this up to any pin, but the way I hooked up my lightning detector, I know that pin 2 is free. So I just kind of took that one. So pin 2, and that's our data line hooked up there. And that's pretty easy. Now, if you are powering your LED strip and you're only going to use a handful of LEDs, you can power it right off this 5-volt pin right here, which you can see I have nothing hooked up to power here. So this is just for demonstration purposes only. You can run it off your 5-volt pin and connect this red wire here, the power wire, to this red wire as well. And that's fine. But because we're going to be experimenting, I don't want to accidentally turn on 300 LEDs and fry the thing. So for my purposes, I created like a secondary power here. So it's going to have its own power supply, and the Arduino is going to have its own power supply from the computer. So a Bounty Hunter Breaks is saying for a 12-volt power strip, you want to use 1.2K ohm resistor. And he's saying that 470 ohms probably would be ideal for 5 volts. And that's what I'm finding. Like between these two added up, I found that it worked pretty well. Like, now one thing, some of these power strips, certain brands do come with the resistor built in. So if you're reading the documentation and you just can't figure it out, it's okay to add. It's okay. It's not going to do anything. So if you're worried or you're not sure, just go ahead and throw one on. It's not really going to affect things. So one of the things you see I'm doing here, now this is being powered separately through this barrel connector here, which is going to connect to, oh, and you guys can't see that. Let me pull it out. It's going to connect to this wall socket, this DC wall socket here, which is set to 5 volts. Now I bought one of those universal wall sockets where you can dial in different voltages. Is it the most accurate? I don't think so, but I think it's not fried anything quite yet. So you can dial it from anywhere from 3 volts all the way up to 12 volts, which is nice for projects and when you're prototyping. So we'll be hooking that up just like that. But not yet. So the other really important thing is where your power is, whether you're powering it off the board or you're doing it separately like I am, you definitely want to include a large capacitor. This is a 1000 micro ohm capacitor, and I'll give you guys a closer look of this connection, or about this connection. Let me slide this into place. So what I've done here is you can see that there's like minus signs here. So that's how you know what the negative end is. And then here's the positive. Also, oftentimes capacitors will have a longer lead on the positive side and a shorter lead on the negative. But don't just go believing that. Some of them people have cut so they're the same length and you're like, uh-oh. So the best way to know is just to really look at these minus signs. So I stuck a capacitor here where the power is coming out. And the capacitor is important because it kind of prevents that on-surge of current coming out and then blowing your strip, and especially if this happens a lot over time. So it's another layer of protection. So you have your basic things like your Arduino and your strip, but then you have two protective things, which are your resistors and your capacitor. Now, I happen to buy a whole kit just like this, and it's got a whole heck of a lot of capacitors up in here. So you can pretty much choose any size. And I used to buy electronic components one at a time as I needed them for projects. But I found that it kind of saves you money, but then you're always having to buy the next size or the next thing. So I started to buy kits and I love it. And for our signal line, it's a braided wire, and I basically just kind of twisted it, and jammed it up in there. Probably easier to tin it and then jam it up in there. But the way that we'll be connecting this for real, and if you guys were powering this off your board, a better way to do it is just to get some of these style jumper cables here. See, they have the little pin end here. And so what you can do is, stick it in your Arduino. Look how much easier that is. And then stick it in your board. And so we would just cut this and then solder the free end to the data line like that and do it that way. But the reason I didn't do it yet is because I have no idea where we're gonna hide this board quite yet. I wanna lay out all of the LEDs first before we start cutting wires and things. So for today's experimentation, I just kind of rigged it up like this, and we're gonna try it and see what happens. And Bounty Hunter is saying, nice electrolytic capacitor kit. Yeah, they have them. They're not very expensive. And so I'm like, man, I've been killing myself buying everything individually, and so it's much easier to go with the kits. Microfarad. Yes, microfarad. Whatever I said, if it wasn't microfarad, 1,000 microfarads. Yes. Sometimes you're talking and thinking about your next sentence and not hearing what you're saying currently. It happens. It will happen a lot. So we have everything hooked up, and the other important thing, if you guys pay attention here, is anytime you're powering from an exterior power source, and this is kind of I learned the hard way because I didn't know. It was my first time with a previous project. So for this one, I knew how to do it. So anytime you're powering anything that the Arduino needs to communicate with, you want to ground it to the Arduino as well. So you'll see that I have from the ground pin of the Arduino, I have this little wire coming to the ground rail of our breadboard. And you can see that from the little power source here, I have power hooked up to our strip. But then the ground, which is this yellow wire here, it's what I had. It's kind of confusing to have white grounds and yellow grounds. You generally want to keep them the same color, but it's kind of what I had lying around. So this one right here is also connected to the ground rail along with the ground of the LED. So everything is sharing the same ground. You want to make sure that the Arduino has a ground of that, so you have a complete circuit. So the first time I didn't know that, and I grounded everything and didn't hook it up to the Arduino, and I couldn't figure out why nothing was working. So that is super important. So now that we know how to hook this thing up, at least on a breadboard to start testing, and then we'll hook it up for real when we're ready to put it on our backing board, I'm going to back us on out. And we're gonna start playing with this thing, right? Let's start playing with this. So the first thing I'm gonna do is there is a program loaded up in here already. And anytime I do this, I like to connect the LED strip first and then the microcontroller. So let's see, let me wake up my computer. And this is kind of weird because we're gonna do coding on that computer over there, but I have this computer because I can't upload code and stream because it knocks the cameras out of alignment. So So this is all hooked up, and I'm just gonna, because this is so rigged up, not great, I'm gonna just push on these, make sure that they're in as much as possible. That one doesn't really matter. And I'm gonna hook this up to the computer. All right, so I'm gonna bring you guys in close to show, to talk a little bit more about power and why it's something that you have to think about, and something that we're gonna have to think about the more we go into this. So check out this reel, and I'm gonna move it so you guys see it better. So here I have all of the LEDs, or just about every single LED of the strip, set to maximum brightness white color. This like eats up a lot of current. And so you can see that it all starts great. Look at this nice white light. And the more it starts to wind and the further away we get from our power source, look at how dim this white starts to get. It actually, in fact, starts turning a little bit red because it's not getting enough juice to power those blue and those green LEDs to help complete the white. And so this is something that you have to think about, that you have to inject power. Now remember, we can inject additional power anywhere along the strip. And so the general rule of thumb is to think about injecting power every meter or so. Then you'll be able to have more consistency in your color. And you can see at the tail end, there's more, you know, a power option here. You can power it midway through the strip. So you can see in this 5-volt strip here, we're getting like massive power loss as we move inward, you know, through this strip, and it starts to turn a little bit red. So that's something to think about. Now in our case, I don't think that power or voltage drop is going to be a huge issue. I think I'm going to be able to get away with powering it from the head and the tail end, because we're only going to use about a meter, you know. So let me check this out, and as an experiment, let me get back up on here in this computer and find my little folder. Not you. Let's see. Let me just pull up this code and see. So right now I have 300 LEDs trying to do its thing, and that's the end result. So say like 60, what did we say? 60 pixels per meter is what I have. So say I only use like 1 meter. You know, let's see what happens. So I'm uploading new code, so you'll see the little lights blink there at some point. Yep, see how the little lights blinked here. And it is asleep. So with 60 lights or pixels, we should be fine. Let me change that to 10. 10 pixels. So if I didn't mention before, it's just wanting to light all of them. So I find sometimes you have to like turn everything off and turn it on, and then it'll like completely refresh the code. So rather than doing that, we're gonna find out in our next examples, you know, how the light works, how much voltage drop we're getting. But this is the most extreme example just to show you guys, like, you know, how it works. And yeah, power is a huge thing with LEDs. But each little light here, you know, each little pixel, I'm sorry, I'm blinding you. I know every time I look at this, I'm like, oh, now I can't use the computer. But each little pixel has 3 LEDs, a red one, a green one, and a blue one. And this allows us to basically, by changing the levels of each, you can pretty much create just about any custom color you want. And that's what we're gonna start doing. Bounty Hunter. So some of your comments look like they're getting deleted, and that's because I think I have some kind of moderator situation going on. Not human moderators, but like bot ones. So sometimes if you ask the question in a different way, it'll like trip, you know, you'll get through. So I remember somebody said via the comments, they were like, show me your doggies. So YouTube was thinking they wanted me to show something else, you know, and he was being totally innocent, you know. So then I said, okay, type it in a different way. You know, it's like, oh, show me your dogs at home or something. And then, you know, YouTube accepted it. So if you find that your comments are not popping up, or if I'm not addressing them, that could be why. So Kurt Bending is saying, wow, I'm assuming he's talking about the voltage drop, because it is pretty huge. And then Bounty Hunter is saying, hey, it's breadboard wire, so the colors aren't as critical. The final design, you should stick with the standard colors for positive, negative, and signal control wires. That is hugely true. With my first, I'm just gonna turn this off because I can literally feel, it's not that hot, but I can feel some heat, you know, coming from these bright white lights. So yes, in the final design, it's hugely important to do that. And we did it with our Fartatokus project. It was like a rainbow while we were prototyping, because months later, if you have to fix it, it's very difficult to remember like what color wire was what. So I usually stick with whatever color wire is coming out of the object, you know. So this one's green, I'll probably stick with a green signal wire for this. Obviously white and red. Usually I use black, you know, for ground, but white is okay too. So we saw the voltage drop, and let's see if we can kind of make this do some cool things. So I'm going to just lay this a little bit better, and in order to kind of prep it, let me just kind of get an idea of what you guys are seeing. And let's see if I can find a way to get this guys to sit this way. And maybe I can build a wall. I'm building a wall here, so this little guy can rest. All right, so you kind of get an idea of the strip, and we're only going to be working with about 20-ish or so LEDs. So I'm going to leave this hooked up. Actually, I'm going to give this a break so it can just kind of recycle. This is an older board, so maybe that's why it's getting cranky with me. So the first thing we're going to do is move on over to that computer over there, and I'm going to put you guys on a quick intermission while I get set up, and we're going to start looking at how to code. And if you don't know how to code or anything like that, and you're like, I've never done this before, that's okay. Neither did I. So I'm going to show you basic code. You don't even have to understand it, but I'm just going to show you where you got to change things to make your own design. So there's only a couple places and a couple things that you have to change, and you're good. So, all right, I'll be right back. All right, so we are back, and the mic should be working. I'm going to keep glancing over here at some of your comments. And Bounty Hunter Breaks is saying, I like the security t-shirt. Glad you survived the Christmas party. Yes, so some of you who love Die Hard, this is the Nakatomi Tower security, you know, as if I were part of the security team. But heck, if I knew John McClane was coming, I'd be like, peace out. I don't need to do anything because he's going to have it handled. We know he's going to have it handled. So the first bit of code here, and I have it up for you guys, and I'm going to look at it for me. You know, might as well bring it up for me. Wouldn't that be nice? So the first one is our color test. Yes. So looking at this code, I know it looks kind of like, what? But we'll go through it rather quickly here. And the program that I'm using is right from the Arduino website. So if you go to the Arduino website, it's a free download. You can download this for Windows, or you can download it for Mac. And it's the Arduino IDE. And when you open up a new file, it's just like a blank file, and you can start typing away your code. Now, also, it comes with a variety of different examples built in here. And let me just, there we go. My windows were, here we go. So you can do digital type projects, things with LEDs, and you can even see down here the lightning detector that we were working with. So anytime you install a new library, you get all this cool new functionality with pre-written code. That way you can just go in and change the values that you need. So it comes loaded with all these kind of beginner-friendly type of projects that you can start going through, mimic other people's projects. That's really the best way to learn. I mean, that's what I do. And then you start to customize them and make them your own. So the first thing we're going to do is download and install this library, the FastLED library, or FastLED. I've heard it pronounced two different ways. And basically what a library is sometimes a product will come with its own library. And it's basically a package that has a bunch of functionality that you can tap into. So you don't have to write all this functionality from scratch. You can kind of just like tap into it, which is great. So in order to put this library into your code, all you do is, I believe it's under Tools, Manage Libraries. So say you were doing this like for the first time, then you can just pick it, pick the library from the list, start typing it in, and it'll come up, and then you can install it. And when you install it and add it to your code, this automatically pops up, or you can handwrite it in after you've installed the library. So that's what this bit of code is for. And there's so much free code online that will have everything written. It's got these little commentaries on it, so you know what to change, what to leave alone. And so all of this stuff will already be there, so you don't even have to really understand it. I'm just kind of giving a very high level view, so when you see it, you have like a basic grasp of what's going on. And so some of you guys that are super advanced at this is like super easy. Hopefully you can chime in with some suggestions for some new folks. Or if you have a better way of doing this, I am always all ears to just improve my skills and all. But heck, these worked, so I figure we play around with them. And Bounty Hunter Breaks is saying, I've not used Arduino or programmed it, but it does look similar to Visual Basic. Yes. They are very similar. And David Beck is already throwing chicken drumsticks at me, because this is like a lunchtime stream. So people start throwing food emojis at me. So thanks for that. Now that's all I'm thinking about. So we've included our library here. So now we can access a whole bunch of functionality. So the first thing we're going to do is define the number of LEDs that we have in the strip. So num LEDs. So how many LEDs do we want to work with? I don't know at this point, guys, until we like lay it out, I have no idea. So I'm going to put 500, so the total number of LEDs that you want to control. Then we have to define what pin is that data line connected to. And remember, it was pin number 2. So if you get a code online, just, put your pin. Say you connected it to pin 5. So change that to pin 5. Maybe you're only controlling 10 LEDs. So you want to change 500 over here to 10. So these really are the only things you got to change. Then if you download code, this will already be there. And that's basically setting up your array, which is a collection of variables accessed within index number. And we don't have to get too much into that. So the name of your array is LEDs, or LEDs. And then the size, which is num LEDs. So rather than putting a number, we've already defined the number of LEDs as 500, so that's already defined for us. So then in this void setup section here, you're just gonna put stuff that runs once. It's like setup. If you were building a robot, do you want your robot to start like this? Do you want your robot to start like this? So it's just kind of like, how do you want this strip to start? And so we want to go ahead and tell FastLED where our strip is, more information about our strip here. So, we're adding these LEDs. So this is my strip. So if I said it incorrectly before, I put the model number of my strip, which is WS2812B, which is compatible with this library. The LED pin, which is defined above here, is 2. So we don't have to put 2 again, it's defined. And then the LED order. Now this is something that we might not know. It's RGB, and you'll notice that in some code that you download, it'll be a different order here, our array, and then the number of LEDs that we have. So, Yeah, we're basically telling FastLED where the array is, and GRB is a common color order. So we'll keep that in mind because right here it's RGB, so we'll see. And anytime you get a new strip, it's nice to do this color test to make sure your LED orders that you're using is the same as on the strip, or else you get kind of like wonky results. So here in the loop section, and we're only going to go over this like once, in the next examples you will have already seen this. This void loop, this is the part of the code that runs over and over again. So basically the Arduino will read down this code, get to this bracket, and it'll basically start all the way up here and go back over it again to infinity, or until it burns up and explodes or something. So what we've done here is in our loop, we're identifying LED 0. LED 0 is the very first LED in our strip. And that is kind of confusing. It's like, it's number 0. It should be number 1, but it's 0. That's how they do it. And I want that one to be red. And then LEDs 1, which is the second one now in our strip, is going to be green, and LEDs 2, which is the third one in the strip, is going to be blue. And then this code here, it's show. So these are the colors I want, now show them, so you have to have that bit of code that says show them. And again, anything you download online is going to have all this. So automatically your eye should go to the number of LEDs, what pin it's connected to. And heck, if you see that they connected it to a certain pin, you might make your life easy and just connect it to the same pin. And then you can, in essence, kind of skip all this stuff. And then you can put in any, heck, I could change this to yellow. I could change this to, magenta. But because we're dealing with red, green, and blue LEDs within a pixel, we just want to make sure that that order is correct. So let's see kind of what this looks like on the actual strip. And this is the kind of annoying part where I wish I could hook everything up to the same computer, but every time you upload code, it knocks all the cameras offline, and then it's like dark for everybody. So I'm going to switch back. I'll be right back. All right, we are back and the mic is rolling. All right, I always forget to turn it back on when I go back and forth. So David Beck is saying to infinity and beyond. Yes, have the light going to infinity. So what I'm gonna do is pull up that sketch. These files are called sketch, like Word documents are called Word docs, Photoshop files are PSDs. So the Arduino files always end in INO. So I'm just going to pull the same thing that was on that computer, but pull it up here. And we're going to do our color test because it's going to download or upload the code from this computer rather than that computer. So it is kind of annoying. So again, I'm going to hook up power to this, and I'm already going to kind of jump you guys here. And then I'm going to upload this. Now remember, it's still got the old program in the Arduino, so it might do that. Yes. So remember when I was trying to get the LEDs to stop lighting all of them? Yeah, sometimes when you unplug everything and replug it back in, look, now it works. And so you can see with our voltage drop, because we're only lighting 10, there's like no voltage drop. It's perfect. So if you're working with a handful, powering it from one end is fine. We're gonna power it from both ends. So here I have this new sketch and I'm gonna upload it and you're gonna see it turn off and turn back on again. Let's see if I can move the Arduino into view. Although, oh, that's a kind of a neat little reflection going on there. All right, and so let me upload this. Upload it. And we wait. And we wait. There we go. So remember in my sketch that I set the first one to red, but it's green. And then I set the second one to green, and this one's red, and then the final one to blue. So our color order is not that great. And on camera, I'm noticing, or at least on my end here, you can definitely tell that's green. Now this is illuminating red. So for you guys, it might look a little yellow. So it might just be the calibration on my screen here, but it is definitely green, red, and blue that we have going on here. So that was wrong. So I have to go change the color order to get this to work. And so I'm just gonna pre-do it here, and then I'll show you guys where I did it. GRB. And if I change the color order and upload it, and we wait a little bit, there we go. Now it's red, green, blue, so RGB. So now it's correct. And I'm gonna show you where I changed that color order over here real quick. And I'll be right back. All right, so here, this is what I ended up doing on the other computer. This color order here is hugely important, and that's why you run the color test. You saw that I just, left it at RGB, but here in a lot of code, you're gonna see this color order. So let's fix the color order and go GRB, because remember that first pixel was green, not red the way I had it here. So we just kind of matched up what we saw, and that, as you saw when I uploaded it, fixed it, so that's all I did in that computer was change this and then save it and then re-upload it. So that fixes that. We have the color calibration working and all that. So let's see if we can move on to actually making it do something, right? I mean, so far it's been like, ooh, all the lights are on, and it's cool. We're accomplishing things, people. But let's see if we can do more. So here, we're done with our color test. Let's do, let's see, maybe we can blink it. So for this, let me put our color test back up again, and let's see if I can show you guys this screen here. And I'm just gonna add it to the streaming software here, so give me a moment. Let me just make sure I hadn't added it already before. All right, yeah, so let me add this real quick. And there we go. And we'll call this blink single. And I know you guys don't see what I'm doing here, but now you should see it. We're just gonna go ahead and do this, and I'm going to do that. Just kind of make it as big as I can for you guys. And I covered myself up, and I shall reveal myself here in a moment. So we'll just do that, and you guys can see what's going on here. Let me see if I can make this text bigger for you, because I know for me, trying to watch it on a video, it's like really tiny. All right, so that should look a lot better. And there it is. So we've done our color test. We know that we have our order correct. So let's try and make it do something. Let's, the easiest thing to try out is see if we can get this thing to blink, right? So let's see here. Again, a lot of familiar things. You have our library we just included. How many LEDs are we going to be working with? I put 10, but we're really going to be working with 1. It's okay to include more than what you're working with. We're still connected to pin 2, so we don't have to change anything here. This is just our array, comes in every code. This stuff too comes in every code. I didn't mention this guy before here. You can actually set the brightness, kind of like a blanket brightness to your LEDs. And you're going to find numbers between 0 and 255 all the time when you work with LEDs. So 50 is a number between 0 and 255. 255 being the brightest, but 50, it's kind of a medium type of brightness. I notice if I make it way too bright, the camera can't really discern the colors, so that's why I backed it down to 50. It's like, calm down, colors. So so that's under our setup. Now this is the loop. This is the thing that runs over and over and over again. So if you look at it, that first LED 0, which is the first LED, I set it to green, and then show. So show me this green LED, and then stay in that state for 200 milliseconds. Then after you're done that, show me the black LED. So LED 0 or first LED, make it black, which means off. And then show me that, show me it off, and then do that for 200 milliseconds, and then repeat itself. So in essence, it's like a blinking. So let's see what that looks like over there. Yeah, I'll meet you guys. Be right there. All right, so I'm back here. Yeah, it's a little bit going back and forth. It's a little not convenient, but it's the best that I can do for the moment. So I'm just bringing up this blink single here, and if I show you guys, we still have this program loaded with our red, green, and blue. So let's blink a single LED and see what happens. So let me upload that. So see, it's blinking. It's blinking green, and every 200 milliseconds, which is what that delay is. So we have, like a blinking situation. And it's green, we're blinking an LED. So it seems simplistic, but now you can seriously start to build upon this. Because what does blinking remind you of? It certainly reminds me of thunderclouds. If you think about it, it's a whole bunch of flashes in the sky. So could we take code like this and create kind of a thundercloud situation, maybe with 3 or 4 LEDs? I think we can, and we can change the color to white, and get it all flashy. I think that might be kind of cool. So heck, let's try it, because that's the first effect that we need to master for our board here is, you don't really have lightning without like some cool thunder clouds as the lightning is coming down. So let's fix that and see how close to a thunder pattern we can get here. So I'm back, and let me catch up on a commentary here, and I'm just leaning to see some of your guys' commentary. DVA Mechanics is here. Welcome to the stream. We're having some fun with LEDs. If you just joined us, we're learning code together, and hopefully not frying anything in the process. But going back to our blink situation here, so we had it blink green. Now clouds don't really blink green, so I'm going to change this color to white. Let's see what that looks like. So white, and it's going to blink for 200, and then it's going to turn off for 200. So why don't we just copy this code and check this out. I'm going to copy it, and I'm going to go here and paste it and do the same thing, but for LED number 1. This is the next LED. So I'm just changing the 0 to the 1 right here. And I think if we leave the delay or the amount of time the same, it's just going to go beam, beam, beam. That's not real thunder-like, we want like boom, 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 like, kind of irregular. So why don't we make this second one like, I don't know, 100? We'll just experiment. 100. And then let's light up a third LED. So I'm going to yet again copy this on and off code, and I'm going to just go down here and paste and back this guy up so he looks all neat like the other ones. And we still want our LED to be white. I mean, we could pick some other colors here, but if you want like a rainbow type of effect for whatever you're doing. So 200, 100, maybe let's just make this 300 and see what happens. Okay, 300. That looks pretty good. And now you see that I'm using a whole bunch, like you've seen some colors like red, green, and blue. So how do you know what colors that you can use, because what we can also do is maybe have like one flash white, one slightly like a lavender or purpley color, and one blue. You know how lightning is not just white, it's kind of like those colors. For now, for simplicity's sake, I'm just keeping it white. So one of the things that we can do is FastLED or FastLED has a wiki, and it's got all kinds of information on how you can use color. And so let me just bring that up and get rid of all these other windows here. And let's see. Where did you go? And here you are. So you can see here, I just kind of got my gear falling asleep on me. So here's the wiki, and it's got all kinds of color information that we're going to get into. And one of the things I like at the bottom here is the different colors you can use, like Alice blue, like that's kind of a nice, really pale blue. That's lightning-ish. You know, here's an aqua. That's a little too, like her, you know, blue. Not as lightning-ish. Here's your traditional blue right here. Let's see. So basically, if you want to make your life easy, you can just copy these different colors and make very custom, you know, colored LED strip. Whether you want to fill the same strip with the whole, like all of them with one color, or, you know, do different pixels, different colors. This is a good kind of chart to figure out what colors are available to you. So I am just going to go back and restore a lot of these examples here, and I'm going to basically repeat what I did here real quick over there, and let's upload it and see how our thundercloud looks. You know, hopefully not too lame, and we're only using the 3 LEDs, and see what happens. So I'll see you guys over there in a sec. All right, so I just caught Bounty Hunter Breaks comment, LED number want to change to 2. You totally caught my mistake. So the very last set there, I totally spaced, and I changed the time to 100, but I didn't change the LED number. So it's gonna try and affect LED number 2. So I never assigned anything to LED number 3. So I'm gonna do that here. I'm gonna make sure I do that here. So thanks for the catch. See, you get to yapping and, you know, having a good time, and then whoops, you forget to change something in the code. So nice catch. And see, and if I remember your previous comment, you were also kind of new to this. So see, beginners catching beginners. I love it, guys. Keep it coming. This is great. So I'm just copying, and I know this is like tedious, you know, to go back and forth from computers. So here I'm assigning LED 1. Let's not forget to do that. And I'm going to make this 100 milliseconds and 100 milliseconds, and that's what happens when you try and do like this fast, you know, to keep it going, and then whoops, you whoops. Now, like Bounty Hunter Break said, remember to change this to LED 2, and I accidentally deleted the bracket. There we go, bracket is back. And we're gonna put that back, and I think I made the last one 300. So there we go. And I will work on a better way of doing this stuff. So I think that, I mean, I haven't looked at it all that much, but I think it's okay. Let me upload that and switch views for you guys. So see, it's kind of like, now we got a pattern. It's like boom, 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 boom. Yeah, because when you look at clouds, they kind of like boom, 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 boom. You know, they and that noise too. That's exactly the noise that they make. But it starts to give you an idea that you can start making these flash patterns, and maybe 3 is not enough. Maybe we need kind of like 4, like boom, 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 you know, or more, maybe even 6 for our cloud. But now we've kind of created a simple pattern, and this pattern is going to continue repeating itself till the cows come home, basically, until we tie it to our lightning detector, where it's going to run so long as it detects lightning, and then it'll shut off because it'll move on to the next thing and sit there trying to detect lightning again. So we kind of figured a way to do our cloud situation there. I think that changing up the timing a little bit, adding a couple more LEDs and spreading them out over our board here, I think we got a realistic effect. So just using some beginner coding, we're getting there and getting the blink example. That example is included in your FastLED or FastLED library. Once you install that, you'll have access to that. And then see, I just copy and pasted blocks of code to kind of repeat, and then you start changing around with the delays and colors. Heck, you can have green thunderclouds. You can have, whatever, or maybe you're building something else. But that's already getting started. So what if we want to light more LEDs? Like, what if I wanted a whole strip of, say, green? Do I have to assign green to every LED, like LED 0, bleh, LED 1, bleh, code? Like, what if you're trying to do it for like 500 LEDs? You got to have like 500 blocks of code? No, you don't. It turns out there's a way to light as many LEDs with one color as you want. And that's what we're going to do next over there. And Dave Wells is saying, that's cool. David Beck is saying, yes, lightning. And David Beck is saying, random seed generator for version 2.0. So we're actually going to get there towards the end of the stream. We're going to learn how to add some randomness. So this stream is all about the different things you can do as a total beginner. Then there's a whole other volume that I can make about controlling color palettes, matrices, fading, hues, color palettes, if I haven't mentioned that already. And that's a whole other tier, also step by step, easy to get there. But I figured for this, we're going to keep it like super beginner. And look, we can already do our project with just some beginner code. But yes, we're going to throw in some randomness towards the end of this stream. And Bounty Hunter is saying, I wonder if they have some example code for random LED assignment. I believe they do. They have like Cylon ones. And if not, get on the Arduino or the Adafruit, again, I've heard it pronounced both ways. I think it's Adafruit website, where people upload their projects and the code is freely available. And so they do have all kinds of patterns that you can take and use as is, or adapt to your own thing by changing the values that you see me changing right here. So, and Kurt Benning is saying, insane trying to build an emo device, are we? Yes, it's getting there. All right, so yeah, they do have all that. So I'm gonna jump on over to the other computer and I'll see you guys there. All right, so here I am. I'm going to sneak in a little bit closer with you guys while trying to keep up with your chat there. So thanks for joining. You guys are awesome. So you're already catching mistakes and things like that. And so let's see here. So this one is kind of interesting, and it might be worth to take a look at real quick. I kind of skipped over this. But let me pull this one up, which is here for me. So you guys see it, but I don't see it. So now I see it. So here we go. So we did our thunderclouds, and we moved the light kind of down the strip manually by going LED 0, LED 1, 2, 3. So say you wanted to just kind of create almost like a theater ticker effect, and have the lights going. There's another function that you can use. So just to quickly show you guys this, again, we know the library. We're working with 20 LEDs. It's connected to pin 2. This is our array. This is all the stuff that's already included. And again, you'll see it's already GRB here versus RGB. So I went ahead and make sure that was already done so we don't confuse ourselves. So here's our loop. And this is probably the first time now we're seeing this for, argument right here. And so for int, which is like an integer I, equals 0. So basically it's saying from LED 0 to all the way from 0 to you reach the maximum number of LEDs, you're going to add one every time. And so here we're starting with like red. Heck, I picked red this time. And so it's going to be on for 100 milliseconds. Then it's going to be off. So it's going to blink once, right? Then here it says now the maximum number of, and it's going to keep doing that. See this plus plus. So it starts with LED 0 because that's kind of how we start. Then we increase all the way to the end of the strip. Now what happens when it gets to the end of the strip? That's what this is for. Now we're going to go back. So it's kind of almost like a Cylon, type of effect. And so this one, for the integer I, we're going to start with the maximum number of LEDs, so at the far end, and we're going to start subtracting 1, so we have this II all the way until we reach 0. So, and we're going to also keep this red, or, we can have it coming one color and then going another color too, but just for simplicity, and of course we show that. So we show it moving along, and then of course, black. So it's just going to go blink, 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 blink all the way till it reaches the end, and then blink, 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 blink back, which is basically what this code is doing. So let's take a quick look at how this works, and then I got ahead of myself. That's why I have notes, but then I don't look at them. So what's the point, right? So let's see how this works, because if you're doing like a kit car, like with David Hasselhoff kit car, or you're doing a cool Cylon costume, you could use something similar to this. There are other very more advanced realistic techniques, but if you're a total beginner, this is a great way to do it, So I didn't change anything here, so I should be able to just upload it. So let's upload it, yeah. And let me just get over there, right? All right, so let me pull this up on here so we can upload it. And it's opening. There we go. And hopefully I didn't jack anything up here. And it's uploading. Let's see. Oh, show you guys, right? I'm sitting here looking at it like, ooh, but you guys can't see it all. Oh, this is a tough color to see, but I hope you guys can see it. It's traveling back and forth. Let me try and change the color to see if it's a little bit easier for you guys to see. I think like, what was it? Blue might have been easy. Let me just make these blue. And I'm going to upload again. And let's see. Oh, that's a little bit easier to see. So you can see with that code, it just travels back along the strip. And of course, we set a delay of 100 milliseconds, meaning hold the current state either on or off for 100 milliseconds. Now, I'm sure if we had done a smaller milliseconds, like maybe 50, it'd be moving a lot faster and you're getting more of that Cylon look to it. And again, there's way better techniques where the LED moves, but the color blurs into adjacent LEDs. So you get a much smoother type of Cylon effect there. But for simplicity's sake, and if this is your first time, heck, we got some Cylon action going here, or kit car action, whichever your favorite movie is. I kind of like them both equally for different reasons. Oh, Kurt Benny meant EMP device. That is what I meant. Yes, I'm like emo. Heck, I'll make an emo machine too. Whatever you guys want. And Bounty Hunter is saying a chaser light. Yeah, pretty much. And so simple code, simple effect, but super useful for different things. And you can have this going. If you put an LED like all around your ceiling, you can have like a chaser light going through the whole thing. Or if you're a DJ and you want to add some lighting, to your performance. You can do something like this. So now we get to the solid, right? I don't know, what page I'm on. Yes. So let's fill this whole thing with one color that doesn't involve us having to assign each LED. Now you already saw that we're beginning to get there with that for statement. That for statement allowed us to write an equation that says, heck, start at 0 and move up to the end of the strip, which we defined at the very top, like 20 LEDs, and then move your butt back down, without having to address every single LED. So we're gonna start to build on that now, and I'll meet you guys over there. All right, so I think, yes, we have audio, we have everything, and the mic is moving back and forth, so sometimes the audio might sound a little wonky as we move things because it's like in a slightly different position every time I move it. So I try and remember where it was. So let's see here. We've done our moving the LED, and let's do, let's try and make some stuff solid now. And let me pull this file up for myself. I've pulled it up for you guys. But it would be nice if I had a copy too, right? All right, so yes, that is the correct file. So again, we're very used to seeing this FastLED library up here is included. We're working with 20 LEDs again. It's connected to pin 2, our array, our color order is correct, our strip is correct. I still have everything set to 50 because it seems like it's best for you guys to see, on camera. I should probably dim the lights more. That probably would help. And then here is our loop. This is the part that runs over and over again. So here's a new command, or a new phrase here called fill_solid. So now that's telling it just to fill solid. And you can say how many LEDs you want to fill solid. So in our case, we are addressing our array up here. So we're addressing that, and I'm going to fill all of them. Yep, I'm filling all of them. And here I have yellow, which I may change the color on the other computer because I think yellow might be a little bit tough for you guys to see. So I'm going to fill this whole strip yellow, and then I wanted to show it. So I'm telling it to do it, and now show me, do what I just told you. And then you don't need this delay here, but I'm keeping it here to remind me for the next step of what we're going to do. So then you can add more colors, so it can go yellow for 500 milliseconds, hold that, and then hold another color. So that's why that delay is there, just to kind of remind me to come back here and add more colors. So let's check out what this looks like. I will meet you guys there at some point. All right, so yep, we got audio. So I'm going to bring up that exact same thing that we did. And let's see here, our solid test. Oops, I deleted the wrong one, or closed out of the wrong one. So let me pull that back up again. And yeah, so this is yellow. Maybe we try it, see what happens. Let me give you guys the prime view. And again, this is supposed to fill it all yellow, so let's hope it works. Let me upload that. And wait a second, it's thinking about it. All right, so that is supposed to be yellow. I don't know, guys, it looks kind of green to me, but that's, we all saw, I put yellow in there. And yes, you can actually color calibrate these things. And that's a topic for, another video. They do have functions that allow you to get the whites more white, make sure all that. Because a lot of times the white will look slightly blue, maybe slightly purple, slightly green, and you can calibrate. So there's definitely functions. Or if you want more daytime temperature lighting or cool temperature lighting, there's presets for all that, but that's a whole other thing. And I think for our purposes, we just want some fun lightning and some craziness going on when that lightning detector goes off, and then we want something kind of cool to look at when it's not. So here I have like a yellow. And one of the things I was thinking of, yep, we're kind of stuck with this night sky over here, right? You know, so I'm thinking maybe when the lightning detector doesn't detect lightning, maybe we can have a cool blue. Like, let's see what an aqua looks like. So let's see here. And I don't have the color chart in front of me, so I hope aqua is a color on one of those charts. So I'm uploading an aqua and see what that's kind of nice, you know, that aqua. And if you think about it, you know, this will be in its frame. And, you know, there'll be like a little cubby along here where we can put like an arch of LEDs that'll be shining down on our scene here and our castle and everything. So a light blue might look nice. We can also maybe start it blue and then have like it more yellow. You know those like sunsets that are kind of yellow, pink, and blue? Maybe we can do something like that for when there is no lightning. And then when there is lightning, then of course, you know, it'll blink white and go all crazy. So we want kind of a peaceful ambiance, unlike my dog who's like barking and says, I don't want any peace. I want it to be crazy, you know, up in here all the time. So is there a way to, okay, so we filled it solid. Like, can we add like a bunch of colors or like maybe have it change colors? So how do we do that? You know, how do we have it change solid colors, especially if you put this around a room? Maybe you want it to start red and then cycle through different colors. So let's see if we can do that, because if you think about it, we can have our lightning scene at the top. Of course, we have our thunderclouds, but the ambiance light kind of flash different lightning-like colors. So it can be like this aqua, white, and then it'll flash kind of purple, and then see, you know, how crazy we can make it. So let's see if we can get like a cool flashing effect using our full solid colors. So I'll meet you guys over there. All right, so we're gonna do this a lot like we did our blinking single LEDs. So here I have yellow, which was totally lame. I mean, that thing looked green to me. I don't know about you guys. So maybe we can do white and have it show for like 200. I think I'm gonna use the same timing as the thunderclouds because we were getting close. I think it needed a little bit more tweaking to really look like thunderclouds. And then, oops. I'm going to take this and I'm going to copy it because we want to do a different color. So let's do, we started with white. I kind of like that aqua, you know, maybe like it can go aqua, it'll flash then aqua. And then I believe I had this for 100. And then we can have it, I was about to type this whole thing. We don't have to type it, we copy and paste. All right. And then this, I don't know. Let me bring up our little thing here and our color picker here. So what's another lightning color? I lost my cursor there for a second. If you guys didn't notice, I was trying to be able to like play it cool. Like, where is it? You know, like looking around the room for my cursor. What did I say? I think there was a color up here that was kind of neat. Maybe like this off blue. What's this? Alice blue. All right, we'll try that. We'll try this Alice blue. Let me get rid of that, and we'll do Alice. Oh, Alice blue. Kind of like that. Yeah, let's repeat that over there and see kind of like how we get, but instead, hold up, there we go. Let's change the delay there. So we'll see what that looks like. All right, so I'll see you there. So Bounty Hunter Breaks is saying, nice, just need a sign to point to the business. Yeah, I mean, I guess you could make some really cool signs with this. Fuchsia. Ooh, that's a good one. Oh, I'll add it into here. So instead of like Alice Blue, because we had Aqua, let's do Fuchsia. That's a good one. Was that on the list? Well, we're going to soon find out. So all I'm going to do here is the same thing. I'm just going to like copy paste what we just did. And yeah, I know, like super annoying to have to double computer this. So I'm going to start with white. And we're going to go 300 milliseconds on that. Then we're going to go to Aqua. And we're going to go 100 milliseconds on that. And then we're going to go to Fuchsia. And hopefully that is a color on the chart. And we're going to go 300 milliseconds on that. And let me verify. If you verify, it'll tell you, oh, it's getting angry at Fuchsia. It's not liking Fuchsia. So let's see if I have a color close to Fuchsia. I have that same color chart here. We could do, let's see here, dark violet. That's kind of a fuchsia color. No, there's fuchsia. Am I misspelling it? I think I am. So pardon me if I misspelled it over in the other. Oh no, I didn't do it in the other one. I totally misspelled it. That's why. It was like, lady, come on, learn to spell. Let me verify this code here. Yes, green check mark. We're good to go. I'm going to upload it. Spelling is important in coding, apparently, right? All right. So you can see that we're getting changes between white, aqua, although the change between white and aqua is kind of hard to see on camera, and that fuchsia color. So I think if we make the colors more dynamic and we change up the timing on them a little bit, then you're going to get a lot more of a, you know, a lot more of an effect. And so, turning it on the side is a lot easier to see. So we can see, and we can also have some black. You'll notice that we didn't do any pixel blacks like we do for the blinking. And I think that would help this out, where instead of changing from color to color to color with no breaks at all, maybe add like black. So there's a pause in the color and you get more of like a, you know, lightning situation. And I think that'll work. That looks pretty good. And Bounty Hunter's like, no, fuchsia, that's outrageous. Yes, I'm on like a few second delay with you guys, ahead of you guys. So I was glad to see that. It was my bad. I've spelled fuchsia wrong, but that's pretty good. You know, so you can see we can start creating some cool party lighting effects, or some, you know, if we add a little green to this, I mean, that's pretty, you know, Frankenstein too. And so we've learned how to blink the strip, move the blink, you know, up and down the strip, how to make a strip just plain solid. Hey, maybe you have a themed party and you just need one color, you know, so now we know how to do that. We know how to switch colors. This is a little crazy, but I'm sure that if you say, I'm going to take out one of the colors, we're going to take out, I'm actually going to put fuchsia. We're going to go from white to fuchsia, and I'm going to increase the delay to maybe something like 1500 on each of these. So we slow the blink down, see if we can get like a nice ambiance instead. And let me upload that. And give you guys a view. So here's the white and here's the fuchsia. See how it's like way more calm, and we can slow this down even more. So say we wanted a theme for when it's not lightning. You know, we want kind of a peaceful, it's getting nighttime type of theme. We can have it kind of very slowly, maybe like every minute, change colors, you know, from a white or a very, very pale blue to kind of a very pale amber, you know, just kind of go from blue to amber, nighttime. I think that'll look nice too, you know, and maybe there's a better way to fade it rather than just blinking it, which there's a function that we would get into volume 2 in order to fade it, because I think we're going to do other things with our window there. So speaking of gradients, we got a single color going on. Is there a way to like have multiple colors? You know, and there's a gradient function that we're gonna do next. So let's check that out. And I'll meet you guys over there. We are back, and I'm going to scooch in a little bit more, check your comments there, so keep them rolling. And so we're done with this fill solid business. Yeah, so we know how to make something solid. Let's learn gradients. So I pulled it up for you guys. I am going to pull it up for myself. I'm just looking for it here. Where'd it go? Here we go. I glazed right over it. All right, so a lot of familiar stuff. We have our library, we have our pins, 20, we're connected to 2. Here's our array. Here's like stuff about our strip, you know, how bright we wanted, still keeping it at 50. So here's our loop, and like we had fill underscore solid, now we have fill underscore gradient, RGB. So we're addressing our array here, which is, you know, here. The number of LEDs, we want all of them, so all 20, so I just put num LEDs. And then let's pick 2 colors. You can have up to 4 colors. So here I have yellow, you know, there's probably a better color than yellow, and aqua. So it should create a gradient starting at the beginning of the strip from yellow to aqua, and it uses its own library computation to figure out all those pixels in between. So that kind of does a lot of the work for us. And here with FastLED, you know, show us this gradient, right? And then the delay 500. So instead of going back and forth, this will give us a solid, you know, we can delete this, but this will give us a solid yellow to aqua gradient, which is nice because you can have the bottom of the picture be more yellow. And then as you move up to the point, that'll be like a nice blue. So you have a nice gradient going on for that nightfall, that sky, that's the sun is setting, you know, although the moon is painted actually on the thing, but you know, whatever, we can have moons and they're usually out at the same time anyway. Sometimes you can see the sun and the moon. So instead of going back and forth, I want to go ahead and copy this and have it like blink or transition from different gradients. So I'm going to copy this over, and I don't know, we can do something kind of crazy. Let's do yellow. Why don't we do like rainbow, like red? Let me copy, paste. Let's do yellow, and we'll make this one green, and we'll make this one blue, kind of like a rainbow. And so it'll blink between that yellow aqua color to our rainbow color. And that's like really ridiculous, but this is just for demonstration purposes. And you know, see, I think the yellow to aqua is going to be really, really nice. So we'll look at that first. And then this bit of code here that I just added, I'm going to go ahead and add after we've looked at the other one first. So I don't have to keep coming back and forth and back and forth. But you guys kind of see like the idea, and it's a lot of just copy and pasting stuff, putting in your own color values, changing pins. It's really not that bad. So I'll meet you guys over there. I am back. Yes, and we got volume and all that. So let's see here. I'm going to get rid of this file, and we are going to go to our gradient file here. And what I'm going to do as it loads up is let's just run that yellow to aqua and see what that looks like. So let me get you guys kind of in this view and upload. All right, it went kind of wonky there, as you saw, but it finally loaded the code correctly. So let me see if I can, whoops, get this in your view a little more. And oops, back it away, back it away. So you can see here, I'm going to gently kind of move this over here. And see where my finger is? That one's off already. So this is our 20 array. And for you guys, and for me too, this yellow is looking kind of green, you know, so it's supposed to be yellow, and then see how it transitions the gradient all the way to a blue. And I'm going to see if I can gently kind of turn it the way I had before. So you can see this finger, this is much easier to see. This looks a lot yellow now. Yeah, it's just the way it's appearing on my camera. It looks a little green, but you can see it starts yellow and it starts to automatically transition. It just does this calculation on its own to our aqua here. So if you think about wrapping this around our point, you know, we can have the aqua at the point and then have, you know, the yellow towards the bottom. So I think that'll be kind of a nice, you know, when nothing's happening type of view that you can look out on, and all that light is going to shine onto our Castle Frankenstein, you know, so a nice aqua blue coming from above, and then we have those yellows or amber light. I'll see if I can find another better color than yellow hitting the castle from the side. I think it'll look really great. And then I want to reserve a couple LEDs to create an amber kind of light effect inside the castle, as if there's like candles on and Dr. Frankenstein is, you know, up to his old tricks again, you know, building creations and things. So we can already do all of that with just the simple things that we've learned so far. We already can do a ton, you know, and the chaser light, we can make some kind of lightning effect with that instead of using the EL wire. It certainly would be a lot easier just to use the same strip, and then use some stuffing to diffuse the actual LED or the pixel bulbs, you know, little pixels, to make it look as one. So we've learned to make gradients and things like that, and we've been using just the colors on that color chart. And one thing with that is that, yeah, you do get a ton of colors, but at the end of the day, it is kind of limiting. Oh, I wanted to see what that rainbow effect looked like. That looked pretty cool. So I'm just going to copy what we just did and do what we did on the computer and add the alternating rainbow effect. So I'm going to do CRGB, red, yellow, green. I'm going to change this aqua to green, and CRGB, blue. See what happens. All right. Let me just make sure I did it right. I'm verifying. Let's see. All right. And upload. Oh, let me give you guys the view. And hopefully it doesn't go like too wonky. All right, so it's doing it. It's going from our yellow to aqua to this kind of rainbow color. And what I'm going to do is just kind of turn this like this for you guys to see. So there's our rainbow and then our nice aqua. So yeah, you know, and then of course the timing is even. It's just 500 on, 500 one setup, 500 the other setup. So you can change up the timing to create kind of more spastic looking things, or you can make the timing much slower so the color switching happens slow. But at the end of the day, using delay, there's another way to do this without using delay, is what causes the jerky color change. You know, there is ways to fade this much better, which we're going to do somewhat next. And we're going to explore another color model, because using the charts is great, and you can stop right here, don't have to watch the rest of the stream, and you're pretty much on your way just using every color on that chart. But if you want to learn to do way cooler stuff and save yourself a ton of headache in terms of changing colors and open up more functionality that's still in the realm of beginnerhood, stick around. We're about to hit some of that next. So I will be joining you guys over there. I'll be right back. So here we are back, and I am getting in close to you guys. And let's see here. I'm going to just go over here. And so far we've been defining color as red, green, blue, like simple color statements. But to really open up what you can do with color, there's a whole other color model. Like we see the red, the green, and the blue here. And remember I was talking about how FastLED, and anytime you deal with LEDs, you're dealing with a lot of numbers from 0 to 255. And you can actually move these numbers around to get a custom color that maybe isn't on the chart. You know, maybe you want a pink that is not so pink, or you want a pink that's like in between. So this is a much more precise way to specify a color. So looking at this, let's look at the R, G, and the B here. And you can see that we can vary the different amounts of red pixel, or red LED, green LED, and blue LED. Because remember, that's what makes up a pixel, is those 3 LEDs. And by varying these values inside that pixel is how you get the colors that you want. So you can see that I have like my little dot over here all the way to the red. So we see that the red is pumped all the way at 255, and the others are 0 because it's like max red. Now I'm going to drag this across the rainbow, and you're going to start seeing kind of what happens. See, red is still holding strong, but we're heading over to the greens. So look at those green numbers move under G there. It's now the green is maxed out because we're in the green zone, and the red is kind of coming down. And now we're trying to trip the blues now because we're heading over to the blues. The blues are picking up, and then soon the greens will go away, and then now back to red. So you can see that by varying these 3 values, you can get some real custom colors. Look, I'm going to go over here and kind of do this blue one, you know, or no, purple one. And so I can copy these colors, these little numbers here, and put them into the code. So looking at a code example, let me get rid of this one, and we did fill gradient. And so let's move to some of these hues right here. And you can see same deal. We included the library, number of LEDs, where it's attached, our array, stuff we've all seen before. So here's another for statement. And you're going to notice that, what's this business here? Like, we're used to doing CRGB, like double colon, or colon, the color, red, green, blue. But now we got these 3 numbers. And that represents red. This is the number for red, green, and blue, just like those little boxes that you just saw as I dragged the color around. So if I go full red and full green, that gives us yellow. So this is like full on yellow and no blue. Now if I wanted red, like full on red, just like you saw, then that would be red. And then of course show us these colors. Never ye mind here. We'll play around with this in a little bit here to kind of show some of the complexities of this. But say I wanted a very custom color. So let's pick one, like maybe even here. So one, let's show this for you guys. So 196, 141, 255. So 196 and 141. I just totally forgot what that was. So 196, 141. So 196 and 141, and this was full blast. That should give us kind of like that very specific fuchsia color, or purple. That's not really fuchsia. Fuchsia's got a little bit of pink, like a little bit of in it. So that's kind of a washed out lavender color, which falls into the family of lightning. So this allows you to very much more precisely fill it. And all I'm doing here is, instead of using fill solid that fills the whole thing all at once, you can have it fill up just real quick from the beginning to the end, really quick. So if you blink, you miss it. It looks like it just came on. So basically all we're doing here is for the very first LED, that's where we're going to start. And all the way up until it gets to the end of our LED string, which we defined as 20 LEDs, we're going to add an LED. So basically with this color, you know, so it starts at LED 0, which is the first LED, and then works its way real quick, because you see there's no delays, you know, or anything like that. And it fills the LED strip with this specific color. And so let's go do that over there. And then, so I don't have to come back here, some of the things you can do is say, hey, you know, what if you want to fill each LED with like a slightly, you know, different color, and you want it to be random? This is something that David Beck, I think, was talking about. So yeah, who is going to stop watching? We want to learn more. Yeah. And then Frank and Azola is saying, I agree, Rachel's an awesome instructor. I took coding class and wish she taught that. I would have learned so much more. Yes. Well, I love to learn by making mistakes and screwing it up and not being like, you know, because I'm not an expert. And so I think like I'm explaining it the way that I understand it. So an expert watching might be like, her terminology is so bad, you know, but heck, I understand it, and supposedly it looks like you guys do too. So say we want to add some randomness to this. So here I showed you how to specify very specific colors that you want to fill your whole strip with. But say you want each LED maybe to be like a random different color. How do you do that? So one way to do it is use our I, so integer, and we're going to multiply it by 10. So every time it goes to the next LED, you know, and again, we're not blinking the LED across. It's just going to fill the strip. So the next LED, it's going to be a multiple of 10, you know, so 10, 20, 30. And then for this one, let's, and this is like random, let's, you know, make it 5. And for this one, so this is going to give us like, I suppose, like a jumble random mess. And I wrote this over here just kind of remind myself to talk to you guys about this. So you can write in these kind of more randomized functions, and then you can fine tune them if you want, but this is going to lead us to the next color model as to RGB is great, but when you start wanting to use a whole bunch of different colors in the same strip, it gets really complicated. So let's check that out. We're going to look at our violet color, that light color, and then I'm going to not come back here, but from there, because you guys already seen this, I'm going to do this and show you this kind of like randomized mess. So I'll meet you guys over there. So Pinball is saying magenta is my go-to. Yeah, magenta's a great one. I can't believe I haven't like done magenta yet. We have to, you know, we're gonna squeeze that one in sometime before we're done here. And so let's see. Let me bring up that file that we were just playing around with over there. I think it was this one. Yeah. All right. Yeah. And let that load up. It's opening. All right. So. I think it was was like 196, 141, and 255. I am like trying to remember what those numbers were, so I think that's what it is. We're gonna go for it. Let me just check. Sometimes I'm typing real fast and then I jumble it. So let's just make sure that there's no obvious errors. And let me switch you guys and let's see what this looks like. So this should be, oh yeah, that's kind of like our little, very light, it looks, you know, bright, but look, if I turn it, it's a very nice little thing here. And maybe I can use a piece of paper, make your guys' life a little bit easier. So, I don't know that helped much. But yes, it's that single color light. It's really nice. And we can change between different colors. So that's another way to call up color other than using bright white, fuchsia, magenta, all that kind of thing. And you can get this very custom color. Now I'm going to do that thing with the eyes, you know, where we're going to randomize the red. So red is going to, you know, increase along the way. Let's see, I times 10. And we're going to do the same with the green. We're just going to start to like mess it up and see what kind of random patterns we can get. And I times 20. All right, let's see what this does. So this is really tough to see for you guys, so I'm just gonna turn it here. So see, we got kind of a neat, because it starts off on this end with very little red, because remember it's I times 10, so we're basically starting at 0 and adding 10 to the value of red as we go down, and then here we're adding 20 to the value of green as we go down, and then 5 to the value of green. So very little green as we go down, and then we're adding 20 to the blue as we go down. And because we're adding red and blue, you can see it starts to get a little more purpley, you know, kind of color. So you can create some cool things just by randomizing things, and that's just kind of like increasing a color as we go up by different amounts. Each LED within each pixel is increasing by different amounts as we go up. So that's kind of a nice palette there. And there are palettes that you can set certain colors within a palette that you can pull. So you don't have to sit there typing in numbers, you know, all the time. And that's a discussion for like volume 2. Bounty Hunter is saying lilac or lavender. Yeah, I think that's like a lilac or a lavender color. So now that we have kind of messed around with the RGB colors, let me make sure I didn't forget anything here. Then we're going to that. All right. I think I got it all. I didn't jump or skip around too much, so I'll meet you guys back over there. All right, so we getting close to you guys, you know. So let's see here. Let's go back to our library here, and I'm just going to get rid of this. And let's go back to this color picker here for a second. So one of the complications that you already saw is if we want to specify different colors going down the strip, working with 3 values is kind of tough. And oh, there's my cursor. I'm like, it disappears sometimes, and I'm looking, you know, around the walls. It gets kind of tough to have to specify 3 values all the time to get different colors, and it becomes difficult to transition between them with code. Not impossible, definitely doable, but to manage 3 different values is tough. So one of the things I'd like you guys to look at is, instead of using this RGB color model here, is look at this HSV. Very similar to RGB, but much, much simpler to use and allows you to code much faster and make more nuanced changes than even RGB. So we started with the basics where you can make it red, green, blue. That's the basics. Then we moved to RGB, which is a 3-value system where you can specify specific amounts of red, green, and blue within that pixel. Now we're moving to the HSV model, which is probably the one that I use the most. And so let's take a look at it. H stands for hue. Hue is just another word for color, like red, green, blue. So that's pretty easy. So you can see here, as I drag this across our rainbow, unlike the RGB, only the H moves. Check that out. Whoops, the S moves because I goofed instead of holding the thing at the top. But if we drag it across, check that out. It goes from like 0 all the way to like 359. And you'll notice that the color at 359 loops back around on the color at 0. So if you're creating color loops, it loops back around on itself. It's pretty easy. And so when it comes to color, you're only dealing with one number again, just like you were red, green, blue, but you have so many more nuanced choices now. Much easier to code for when you're only dealing with one number. So what is S? S is saturation. So that's like how much pigment do you want in that color? So you look at our red starts fully saturated at 100%. Now if I drag that down, look at the saturation drop and look, it's starting to get pinker, pinker, pinker until finally there's just no color at all. It's white. So that's how saturated do you want your color. So I'm going to leave that at 100%. Then V stands for value. It's also sometimes called level, and that's just another word for brightness. Like how bright do you want this LED or this pixel to be, or this color? So I'm going to drag over here. This is at maximum brightness, 100%. And now we're going to start dragging. And the biggest thing you're going to notice is, obviously that fades to black because it's super dark. It's, 0. It's got no light in it, so it's like a dimmer switch. You can think of the V as a dimmer switch for your color. And then S is saturation, how much pigment you want in your color. So if you have a bucket of white and you put in only a little bit of red, it's going to be very pinky. And the more red, you just want to overpower with red until you get to that very bright red. So that's the way you can think about it. Although mixing light is not so much like mixing paint because it's additive. So if you add RGB and you put the full colors, you get white, which you don't in paint. If you were to mix red, green, and blue with paint, you ain't gonna get white. So light is a little bit different than paint, but I'm trying to make some kind of understandable, analogy here. So that the HSV has a lot of advantages. Not that one is better than the other. It really depends on what you're building. I'll be honest, I use HSV a lot, but I also use just the usual red, green, blue, from that chart. Way easy when I'm not doing something complicated or I'm not doing a ton of animations. That's a great one to use. So let's play around with this HSV situation here. And I'm just going to get rid of that and let me see. Bring this guy back up again. And I will bring it up for myself as well. So you guys are looking at it. And here it is. So, no, not that one. Let's do this one right here. Wrong one. I lied. And let me bring this up for myself. And I have way too many of them. Here we go. All right, so let me just, where's my mouse? Here it is. So that's not it. There we go. I'm trying to read like the, so I think it's this one. It might have gotten discombobulated, which I'll add it if it did. Here we go. Use single. Oh, I get what I did. All right, give me a second, guys. Give me a second. And nope, that's not it. There we go. I believe that is it. All right. So note to self. Don't call files really similarly together. You know, then you have to remember which one it is. So note to self. All right. So what are we doing here? We included our FastLED library or FastLED. Number of LEDs that we're messing with is 20 again. Pin, our array, you know, so a lot of things that you're already used to. And we're going to come back to this here in a second with this uint8 underscore t. It's an unsigned number between, not unassigned, unsigned. So that is a spelling mistake. Unsigned number between 0 and 255. So numbers that we're super familiar with by now, you know, 0 to 255, and all of our three values take that. So whether you're using RGB and you're specifying different values or different amounts of red, green, and blue, or you're doing this hue, saturation, and HSV, hue, saturation, and value, or the V can also stand for level, which is our brightness. You're always going to be working between 0 and 255, 0 being nothing, 255 being max. So here, it's other than this, everything else is the same. So getting into our loop here, and we'll get back to what the heck this is here in a moment. So for our loop, another for statement, and we've seen it. So we're going to start at the beginning. So our LED I is going to start at 0, which is at the beginning, which I've said 500 times. So I'm sure you guys get it by now. And so as we proceed up to the maximum number of LEDs, which we specified as 20, it's going to increase by 1. So this again fills all LEDs with this color. So we've seen this one before where instead of just fill solid, where it's like, boop, all of them are on, this one fills it like real quick like that. Different effects, like is one better than the other? It really depends on what you're going for. So here with our LEDs, we are going to specify a hue for our LEDs. So instead of RGB like we were used to, or CRGB, this is CHSV because we're using a different color model now. And here you can put whatever hue you want. So let's say I want red, you know, that would be 255, you know, or no, the hue color chart is a little bit different. Let me bring that up for you guys before we get too far into what we're doing. So let's see here, and I'm going to go back to my mouse. Oh, there it is. It likes to escape. Let's go back to here for a second, and I'm going to scroll up and show you guys something. So remember when we were doing the color picker and it went from like 0 to like 300 something, 359 I think the number was, and some of you might have thought, well, heck, you just talked about like 0 to 255. This goes way more than 255. So what the FastLED library has done is converted the numbers to 0 being red and all the way up to 255 basically being almost red, and then it cycles back to the 0 here. So you can use this chart to kind of help you pick out where you want to be in the color spectrum. So you know that 0 is going to be red, like a blue is going to be like about a 160-ish, you know, something like that, aqua 128. So instead of using the RGB colors, you're now using these hue colors. So it's much less to remember. So going back to our code here, and let me, oh no, I gotta find it again for myself, and then I'll put it up for you guys here in a sec. Nope, and that one. All right, so let me put it up for you guys. So this one here. So if we wanted it to be red, we would put 0 because that was red. And we wanted it maximum saturation. We want it fully pigmented. Now, if I wanted something with less saturation, I can go like 150, you know, all the way down to 0, which means like no saturation at all. So I'm gonna leave that at 255. And then the brightness, the value or the level, I want it maximum brightness. So that'll fill up the LED strip all red, right? But there's a cool trick that you can do in that since this is the hue value here, we can just call it hue, right? And instead of delay, remember we were using delay a lot to hold a certain color before changing to another color or changing to another one or to create our blinky things. A much better way to do it is using this argument or function here. Every n milliseconds. You can go every n milliseconds, every n seconds, every n microseconds, I believe, and then specify it in these parentheses here. So what we're going to do here is, and Bounty Hunter Breaks is saying, any chance you might use your violin playing for the intermission music? Ooh, that's a good idea. I should like compose some originals and have like original intermission music. That's a good idea. I'm gonna plant that right here. I'm just gonna, take that and put it in my pocket. I'm gonna put that in my pocket and then pull it out later. So that's a good one. I like that. That's a good idea. So where were we? Yes, so every n milliseconds, every 15 seconds, we're going to change the hue by the time period indicated here. So yes, 15 seconds is what we indicated. So hue plus plus. So the hue is going to increase by 1. So the hue will go all the way to 255 and then return to 0 because of this uint8_t setting above. So one question you might have is like, okay, so say the hue gets all the way up to 255. That's the end. Will it go to 256? No, that's what this is for since we set it to 0. It's going to loop back around on itself and start back again at red. So we should get it like a continuous looping kind of rainbow color as it cycles through all of the hues on that chart. So we're going to go ahead and look at this, and I've already shown you how to basically put in whatever hue color you want. Like a 160 is a nice icy blue. And you want it at full saturation. Maybe you do, maybe you don't. I said you want it at full saturation. No. Or select your brightness level here. So you can set colors manually like that. But what we're going to do is kind of cycle through some colors in a nice way by just using hue. And then we've already specified our hue values here to start at 0, which is red. So let's check out what this kind of color changing thing looks like on the actual strip. So I'll meet you guys there. All right, so we are back and I'm going to bring up that sketch. And guys, we are kind of like crushing, this. Like there's so much we can already do with just some of these more beginner things. And it's loading. All right, now it's up. So rather than show you, like I said, the single color, you guys get the idea. 0 for red, you spit it out, it'll show up all red. So instead, let's look at that color changing that I was talking about. And let me upload this and switch. Like positioning it. So see, I'm going to turn it on its side. So every 15 milliseconds, it's increasing the hue by 1. And the big difference is, look at that fading effect. It's a much nicer fading effect than the delay stuff that, we were doing. Plus the, Timothy Hope is here. Hello, everyone. So hello to you and welcome. You're kind of like coming into the middle of our LED crash course here, but that's cool. Like there's still lots to learn. David Beck is saying intermission dance party. Oh, don't tempt me. We should like put up a bunch of LEDs and be like in the club every time that there's an intermission. But I hope to decrease these intermissions as I find a better way to do the coding, because in the beginning we weren't doing that much coding, but now we're getting more into some of these electronics. So I have to find a better setup. So anyone that has a better idea than the way I'm doing it, I'm all ears. It seems like anytime you upload code to the same computer that's streaming, it knocks all the cameras offline momentarily. They do come back up, but I'm always afraid that they won't come back up. So it looks like Kurt Benning is trying to say something, but he got nabbed by the moderator bot there. So definitely post it up again and and ask it in a different way. But it looks like I also have another chat open that is less moderaty. And Kurt's saying, so I have an idea for a summer project: modify a Chevy Impala from 2000 to 2005 for more horsepower. I know it's late, but it's a good idea. What do you think? That's always a good idea. What are you talking about? That's an awesome idea. I just need some time to put it together. So I think we've cycled through this quite a few times during our conversation, but I like that. That's kind of a nice effect. And rather than the gradient, which I really like, we can do gradient fades like this, or we can make it all one color where very slowly, maybe even over a period of an hour or 30 minutes, it fades from like that amber color to an icy blue to a darker blue, and then of course the lighting for our lightning is going to be more crazy. But part of this was trying to find a neat lighting scheme for when there is no lightning, day to day, what this thing looks like. And of course we have our mini fog machine set up, so that's going to go off periodically, where Dr. Frankenstein will have made some oops in his lab, as much like we do here a lot, and have that fog machine go up like something exploded, or something went horribly wrong in his lab. And have those amber lights kind of fade in and out, which is something we can do similarly using code like this, and adjust the level, that level, or the V, which is our brightness, and kind of make that amber light go up and down, or a little bit like a flickering candle. So now you guys see kind of how we can start doing this thing, or we might use delays to make it more sharp, flickery. So the only downside to using delays is that when there's a delay happening, say it's for 500 milliseconds, your Arduino does nothing. It's in that pause mode. So it's not detecting lightning. It's not, running anything. So delay really holds it up. Short delays aren't that big of a deal. And because we are detecting lightning, the lightning will happen. It'll kind of do its song and dance with the lighting, and then it'll start detecting again. So unless we get like lightning that is back to back within like milliseconds of each other, which can happen, we're not going to be too much in trouble using delays. It's more if you're running a lot of other functions that are super important and they happen really fast, the delays can kind of trip that up, because it ties up your Arduino. It's just going to sit there and wait for that specified time. So using every n milliseconds, seconds, microseconds is a great way to avoid that, avoid that whole thing. And you can see it kind of just gives a nice little gradient effect. So using the HSV opens the door to a lot of other ways to look at things. So that's I think we're slamming through. So right now we've made each LED the same color. It is pulsating from different colors, but they're all the same color while doing that. So what if we wanted to make our LED different colors, like make each one, maybe we could do a rainbow effect or something. And so for my purposes, for the lightning detector, I probably won't do it, but I wanted to do this for you guys in case you have a cool project where you want to do more multicolor things using this HSV. So let me load that up on the other computer, and I'll meet you guys there. Dance party, intermission dance party, everybody. Let's clear the club. We're coming back on. Clear the dance party in the mission club. All right, so what are we talking about? Multicolor. See, I got to partying and I totally forgot where I am in our thing here. So let me bring this up for myself. Let's see, where are we? Not that one, not that one, not that one. I think it's this one, right? Yes, all right. So just making sure they're coordinated. All right, so for this, a lot of things we already recognize. The library, how many LEDs, where is it connected, our array, our value here, our uint8_t. I'm not going through too much detail over a lot, like nitty gritty, because a lot of the code that you're going to download already has this for you. So as long as you know where to change the values. So if you see RGB with the colon, then you know, okay, and they're using red, green, blue, like the words, then you know to stick with that. If you see RGB where they're using the RGB values, then you know how to stick with that. And that's why I wanted to take it one step further, because a lot of them you'll see this HSV situation. So now you're armed with this, so you can go online, find cool projects, download the code, and know how to change the pertinent areas of the code for yourself. So there's a lot you can do without knowing how to actually write this stuff out, you know. Heck, I don't know how to write all of this stuff out either. You know, I always need a reference or a guide. So looking at this, you know, the loop, again, we're going to fill all the LEDs with the color we specify. So starting at I equals 0, so starting at LED 0 all the way up to the maximum number of our LEDs, which we specify 20, we're going to increase by 1. So, you know, like that, with that sound effect too. Yeah, this is exactly what it sounds like when it does that. So here's our LED array, you know, from above, I. And so instead of, you know, RGB, again, we're seeing this HSV. So we're going to take the hue and we're going to add 10 to it every time. And we're going to have maximum saturation and maximum brightness. So hue increases by 10 for each LED. So remember, increasing the hue, 0 is red. And the more we go up, it turns all the colors of the rainbow and then cycles back to red again. But we're just going to do a rainbow on the strip, and then that's it. So then what's going to happen is we're gonna like, you know, make this a little bit more challenging, or kind of a neater effect. So for every n milliseconds, you know, so every 15 milliseconds, we're gonna change the hue by the time period indicated here. So hue plus plus. So what's gonna happen here is initially when it fills up, it's gonna fill up like a rainbow, because we're gonna start with LED, the first LED being 0, the second one being 10, 20, 30, you know, increases by 10. So it's gonna go down the rainbow that way, maximum saturation, maximum brightness. So when it originally lights up, that's what it's gonna look like. Then within 15 milliseconds, or the first time that 15 milliseconds elapses, which is quick, so, you know, watch it, the hue is gonna change by 1. So it's almost gonna be like a rainbow effect moving down the strip, because now if LED 1 or LED 0, which is our first LED, is no longer 0, which is red, now it's going to increase by 1. So now it's 1 plus 10. So now it's 11. So you'll see it like cycle through some really cool colors using this code. So I'm going to just upload it on the other computer, and we'll check it out. I think it'll be pretty cool. Hopefully, if I didn't screw anything up. Alrighty. Intermission party is over, people. We are back. And Timothy Hope is saying, love the multicolor. I do too. There's just so many cool things that you can do it, and you never have to settle on one color. And I especially love it when they kind of like transition. So this has been running, you know, the whole time. And then Frank Andazola is saying, this looks awesome. Halloween decor. My black cat loves Halloween. Halloween is my absolute favorite holiday. I love Halloween, and it's like mandatory. We're going to do a very cool Halloween build. We have to. I mean, it's my favorite. And it's going to include LEDs, you know, because that's how we make it all spooky and spooky ambiance. So yes, definitely my my favorite. So yes, multicolor. Let's get back to it. You know, I get to chatting with you guys, and which is always fun. I love it. And let's see, I think this is the one. We'll see. I'll recognize it or not. Yes, this is the one. So I'm just going to go ahead and upload it. But before I do that, let me do this. And I'm going to hold it like that, because it seems to be the easiest way to show you guys what's going on. Let's see. Now I'm going to use the other hand to try and push the button. So let's see. It's thinking. It's thinking. Oh, there it goes. So see that rainbow kind of moving? So when it initially loads, it's very tough to see. In milliseconds, 15 milliseconds, it's kind of like a nice little crawl. So when it first loads, it's a rainbow. And then, of course, we're adding 1 to the hue each time, plus 10. And then, you know, exponentially doing that down. So it moves, it gives the effect of the rainbow moving down your, you know, your strip there. Now, we could do these cool moving effects with certain colors. We don't have to use all the colors of the rainbow like we're doing here. Like for my project, maybe moving between an amber, orange, and different shades of light green and blue might be something kind of neat, where it does crawl up and down very, very slowly. And again, you won't see the LEDs. So it's going to shine kind of different lights around the castle. So something like that might be cool too. So I definitely want your guys' opinion on this, because basically, you know, I just go with what you say, because you guys usually have like way better ideas than I do. That's how we got into this like big lightning detecting window thing with, you know, young Frankenstein's castle and all these really cool effects that will be set off when lightning occurs. So Timothy Hope is saying perfect speed. I think so too. Like the 15 millisecond is very, for this effect, it's very nice. Even the color changing one was pretty nice too. Some people like it, you know, crazy. Other people like it much slower. We can do, let's see what faster looks like. So let's increase it to, let's go nuts, like 5 milliseconds. I don't even know if we'll be able to see this. It's so fast. So let's see what happens. I'm gonna hold it. Oh, it looks like it just uploaded. Oh yeah, look guys. That's pretty fast. Like a little caterpillar of color walking. That's pretty nice. That's cool too. And then you can also have it like a Cylon where it moves back and forth. So the FastLED or FastLED library has a ton of really, really cool colors or cool patterns that you can try out. And then now that you know the values that we've been modifying over and over again, you modify them on your own, whether they use the text colors like red, green, blue, whatever, modify those, modify the RGB colors or the HSV colors. Now you know how to do all of that, how to copy and paste blocks of code if you want to change colors. So it's not, you know, it's not that tough. And when you verify it and there's a problem, it tells you exactly what line you're having the problem. The forums are really cool for posting code. I've posted when I get really stuck and I'm like, I just don't know what's going on. And oftentimes it's a misplaced semicolon or just something misspelled, something really dumb, you know, and then I'm super embarrassed. But everyone's really supportive, and that's how we learn. You know, this was, you know, I only learned this a couple days ago. So if I can do all this in a couple days and look at what we've done in a single stream. So there's only one more example I'd like to show you. We've shown articulating through different colors. What if you want to animate just like within one color, you know? And we've animated hue, but we've done nothing with saturation or the brightness. So you can set the hue to blue and then just vary the saturation and the brightness, and that gives you all kinds of blue tones that you can just do that way. And also that starts introducing some of the randomness that David was asking about. So this is going to be our final example, and I'll meet you guys over there. Intermission dance party, everyone. Party to the close, people. All right, let me get closer. Let me get closer, you guys. So where are we? I'm gonna get rid of this, and we are going to look at this one. And let me bring it up for myself here. I think it's, nope, I think it's this one. Let's see. Yes, it is. I picked the right one. All right, so really familiar things, our library, how many LEDs we're dealing with, where is it connected, our array, our hue equals 0, this Inuit 8 underscore T value here, our setup, which is where everything's connected, the color order. So far, I haven't touched the brightness. I've left it to 50 because I thought that for streaming, it might be a little bit easier to see, whereas brighter colors sometimes like blow out the camera. But you can set this all the way, 255, all the way, you know, if you want. Or you can make it like really dim, like, you know, super dim. But I'm going to set this back to 50, something like that. So here we go with the void loop. And there's, oh, I remember why I did this. Sometimes I gotta remember, like, this will be a good example. And then later when I'm presenting, I'm like, that's horrible. Why did I come up with that idea? So anyways, let's skip this here for a second. And let's set the color for our first pixel. And this is how we're going to learn how to copy one color from one pixel to the other. You know, so far we've been setting them individually when we were using the old, not old, but like, you know, old for this stream, red, green, white, the words, colors. And then we went to RGB and all that by fill, you know, and then we were beginning to fill the strip. So for this, what we're going to do here is set the color for the first pixel, which is LED 0, confusingly so. So LED 0, we're going to set this to a 160. 160 is like a cool icy blue. And here for the saturation, how saturated we want it, I put random 8. Now, random 8 means that it's just going to choose a number from 0 to 55 randomly. And then for our brightness, again, I put random 8, but this time I put some parameters in there because I don't want it to go all the way dark, like to 0. That's like off, you know, so I wanted to go dim to maximum brightness. So I put like 100 to 255. So it'll randomly choose a number within this range for our brightness. And then we're going to copy each pixel to the next one from the end and move our way forward. So we've done forward to the end. This time we're doing end to the beginning here. So here's our for statement again. And we're going to start with the maximum number of LEDs, and which is 20. And then we're going to go subtracting 1 every time this thing runs. So minus, minus, all the way till we get to 0. And then we're going to take the information from the LED and then move it to the next LED down the row as we get to the head of the strand. So hopefully all that kind of makes sense. So we're basically saying for the first LED, this is the color that we wanted, this icy blue. Pick a random saturation, pick a random brightness. Okay, that'll be set. Then we're gonna copy that and that's going to go down each LED. And every time it runs, it's going to choose another random value to go down. So you'll see all these like random blue shades of LEDs or pixels moving down the strip and keeping us within the blue spectrum. So that's one way to stay within the blue spectrum. And when we do this, because there is no time value like every n milliseconds or delays or anything like that, it's gonna go crazy. It's gonna go crazy. So what I've done is anytime you see slashes, it means it comments it out. Notice how it's kind of like grayed out. It allows you to put commentary for people. So if I uncomment it, see how it activates it? It becomes black. So we'll activate that. So it's going to move down every 50 milliseconds. So that way you'll see kind of the changes. If you don't have that every milliseconds, it happens so fast sometimes, it's tough to tell what you're doing is working. So what I'm gonna do when I get over there is first put it with the no milliseconds, so it just goes nuts. So it's almost like a theater, thing, a theater chaser. And then we'll put the milliseconds in. So I'll meet you over there. Intermission party, oh yeah. Party on down, people, party on down. And we are back. All right, so can you let the computer pick the colors? Yes, in essence, that's kind of like what we're doing with the randomization. The program just like picks a number, and you can also randomize the hue. Like you saw, I put 160. Or you could put random 8 in there as well, and then it just goes, it'll go all nuts, so you can have like a rave, I guess, a rave at the club at that point, which is what I should do for my intermissions. I should just have it all randomly going nuts. And then David Beck is saying, new dance, do the light flash. Yeah, well, I know the disco, that way. But I don't know the light flash with all the emojis. All right. So lots of good ideas here, people, that you have been chiming in. So I'm not taking them. I'm taking them from the comments and I'm sticking them in my pocket. Yeah, to use later. But in the meantime, go thinking about a lighting scheme for when the lightning detector does not detect lightning. Let me just pop this up while I talk to you guys. Well, the lightning detector doesn't detect lightning, and obviously one for when it does. And when it does, we'll have our storm clouds going. I think that if we flash the LEDs up at the top, like white or similar lightning colors alternating, I think that'll make a good effect. And then for when it's not lightning, have kind of a nice peaceful ambiance, a nice amber flicker inside the Frankenstein castle, along with, the smoke machine that we set up. So let me just look at this real quick and let me make sure it's correct. Because sometimes I'm like, with my hands, or you touch something and you add some kind of comma or something somewhere that it shouldn't be. So I'm going to go ahead and upload that and turn it like this. So this is without putting the milliseconds. See how it's randomly changing the, it's like moving in a straight line, although the eyeball is tough to see it because it's doing it so fast. But basically it starts with 1 pixel and copies that information, the exact same information going down, and then it starts again with another, again, 160 for the hue, so same color but different saturation and different lightness, and it goes all the way down. So I'm going to slow this down a little bit for us to see what the heck is going on here. So let me add that every 50 milliseconds. And I'm going to upload that and hold that a little bit easier to see. See, so now you can see it's a chaser. And you can see each LED chasing down, it copies, so it's the same color going down, but then the one after it is another random, like, saturation and lightness, lightness, darkness, the value or the level. So that's like one way to do some cool things within the same color pattern. And that kind of brings us to, I would say, kind of the volume 2, which if you guys are interested, I will definitely dive into with you guys. Where am I diving? What the heck? What the heck's going on? Somebody give me some food. It's I blame David for posting chicken legs, because that's all I'm thinking. Like diving into the food. So I'd be like totally happy to dive into a volume 2 where we look at very cool, more futuristic, more nuanced effects with more professional results, like fading, blurring, where like we've done the Cylon, where the LED kind of moves up and down, but like I said, you can blur that color into other LEDs, so you really get that true kit car look. And like kit car is not just one LED going back and forth, it's like a group of them that go back and forth. And so we can look at doing those effects, waves, sawtooth waves, pixel matrices. There's a whole bunch of ways to really put very precise control, especially if you're building a costume or you're building a mask, which is like all, covered in LEDs, then, we can definitely get into all that. I figured for today, a good volume 1 is getting us to the point where we can move with our lightning detector project, get really cool results for it, and make it very beginner friendly. Heck, I've never coded this stuff. I'm sure a lot of you have never either, but heck, looking at some examples, figuring out where to change things, opens up a lot of doors. So I hope you guys had fun. I know I certainly did. I love uploading code, and you're kind of sitting there like, oh, will it work like I intended it to work, or is it just going to be like a big jumbled mess? Or from the get-go, if I had forgotten the capacitor, who knows, maybe I would have just busted the whole thing, and then I'm like, oh, we got no LED strip. So you never know how these things are going to go live. So that's why I love having you guys. You guys help catch a lot of my mistakes. So a lot of the code you saw, you can copy from the video. If you are a Wrench Army member, I will be posting every single example that we did onto Discord, also onto the website if you signed up and you prefer to download it that way. YouTube members and Patreon members, you can get it on Discord. So make sure your account is hooked up properly. If it's not, I have a help guide to help you. But yes, you get all of this, and you get a lot of the project plans. Once I'm done the project, I figure out, okay, how do we put this together? And I write a detailed thing. So check it out. You can join on... you can join basically in a bunch of places. You can join on the website, you can join on YouTube, and you can join on Patreon. So you can join on whatever the platform that you feel like, you'd have the most fun on. But regardless, I'm equally on all of the platforms. The best place to chat back and forth with me is Discord. Even if you're not a member, you can get on Discord and chat with me. Wrench Army members, you get a special section on Discord for us to chat projects, upcoming projects, some of your suggestions on what you want to see. So thanks again, guys, for joining me. I had a blast, and I'm going to get to getting all this stuff online for you. In the meantime, while I do that, you guys think of some cool lighting ideas, even if you want to post some videos to cool things that you've seen that we can incorporate into our build. And I'll catch you next time. Bye!